Hello and welcome from Australia. Today I'd like to take the opportunity to talk to you about the work that was done to enable a building code change to occur in Australia for 8-storey timber buildings. I'll give you background as to where timber construction has come to from in Australia, talk about the building code non-combustibility requirements, a bit about the comparative full-scale fire testing, describe the multi-scenario fire risk analyses that were undertaken to enable the code change, describe what the code change is, and give you some background as to where you can find some further information in terms of the fire analysis. Australia's predominantly been a timber-framed country, building 1- and 2-storey domestic houses. Back in the late 1980s, a major research project was undertaken to investigate the fire performance of timber frame buildings in apartment developments. For the first time, a risk cost assessment model was used to evaluate the fire safety of these buildings. As a result of that work, a code change came into place, which enabled 3-storey timber frame buildings, timber framed apartment buildings, to be built in Australia since around the mid-1990s. One of the key reasons that changes occurred slowly is that our building code has a requirement for non-combustibility from a construction perspective. So for buildings typically of either 2 or 3 stories, and depends on the type of building, there are non-combustibility requirements. And for some building elements, those elements need to be either of concrete or masonry construction. Some comparative full-scale fire testing work was undertaken to look at the potential for increase in fuel load or fire severity due to the use of combustible construction, that is timber frame construction. So 2 identical tests were undertaken, one using timber framing, the other one using light gauge steel. The same fire load was used in both tests, quite a high fire load. This is a fire load that was deemed to be in excess of the 90th percentile for hotel, motel style developments. So identical tests were undertaken, and we've got a curve here, or a graph here, showing the temperature profile of both tests. So the brown line, if you can follow my cursor, and the blue line adjacent, the brown line being the timber framed and the blue line being the light gauge steel test. So basically what that showed us was that the performance was in effect identical in terms of the temperature within that compartment. So there's no evidence of increased fire severity in the timber frame test. So the test went through the traditional fire phases, through to having our maximum temperature occur, and then through to the decay phase. So the test demonstrated that with these fire protected systems, so using in this instance fire grade plasterboard, that the timber frame did not contribute to the fire, and there was no difference in fire severity. What was interesting in the test, however, is the time to failure of our plasterboard systems. For our non-combustible frames, so our light gauge steel, the failure was around the 66 minute mark, which is what would be expected. Our timber frame systems failed at around 114 minutes. The key difference between the both sets is that the non-combustible frames had insulation, which was non-combustible. The timber systems had combustible insulation, and that caused the failure in the timber system. So the performance was very well demonstrated that the timber in a fire performed very well in relation to its response. Under our building code has some mandatory requirements, which are deemed the performance requirements. So every building needs to achieve the fire performance, health and amenity, energy efficiency. So the key performance requirements are stated, and there are basically 2 ways or 2 pathways of compliance. One is doing a performance solution. The performance solution is typically undertaken from a fire perspective by a fire safety engineer. So you can come up with a new design that meets the performance requirements, but isn't what's termed a deemed to satisfy solution. A deemed to satisfy solution is basically a recipe. Follow the recipe in the code and you comply. That was the focus for the timber change. So the timber change was all about providing some guidance or some recipes as to how you can build a compliant building system. Now, the types of systems that we're talking about are fire-protected timber systems. These can be either our light timber-framed building elements or our massive timber systems, as we term them here in Australia. So our lightweight are a traditional stick frame, and our massive systems can be your cross-laminated timber, laminated veneer lumber, etc. So they are protected by fire-grade coverings. These buildings also require the use of sprinkler systems throughout. So this is the change that was requested to go beyond where we were previously, which is for apartments and hotel developments. The performance requirements in the Building Code of Australia, from a fire perspective, a couple of the key ones are stability during a fire and obviously fire spread. So looking at spread both within the building and beyond the building. As part of looking at those performance requirements, you need to look at the function of the building, so hospitals or educational buildings, the fire load that can be present, the hazards, any other hazards, the number of stories in that building, etc. So there are a range of things that need to be considered. So undertaking the proposal to change the code to enable timber buildings, all these aspects had to be addressed. So in addressing those criteria, a probabilistic risk-based approach was undertaken. So looking at a range of fire scenarios that could occur in the range of buildings. So things you need to consider are, the frequency of fully developed fires, the smoke spread throughout the building, detection alarm systems, occupant response, fire brigade intervention, etc. So there's a range of things that need to be considered, which were as part of the analysis. So looking to enable us to build timber buildings up to 8 stories, first there was a comparative risk analysis was undertaken just based on published fire data. This was to look at the performance of various classes of buildings and enable us to group them into high, medium, or low risk type buildings. The previous analysis that we'd undertaken back in 2016 was for these apartment, hotels, and office type buildings, and we used that data to then extend to other classes of building. So as I mentioned, there was a comparative fire risk assessment undertaken where we grouped the various classes of buildings to either a high, medium, or low risk. But there's also a qualitative risk-based analysis that was undertaken to compare the fire risk and looked at the performance within each of those classes of buildings. So we also use those to identify where some analysis wasn't critical, but also to identify the critical areas that required further analyses. So for the medium risk buildings, we looked at the occurrence of fire on the upper level of an apartment building. Obviously apartments, because people have the ability to sleep in those apartments and may not respond to fire cues of high risk. And the worst scenario is having an 8-story building with the top level apartments with a fire occurring, and then having to look at the occupant characteristics and ability to evacuate, as well as any other emergency management systems in place. And one of the key risks would be where you've got a retail building at the ground floor level, which may have an extremely high fire load. In looking at that comparative risk assessment, so our traditional non-combustible buildings deemed having a risk of 1. Via the analysis, we demonstrated that the timber frames had a comparative risk of around 0.16, and the massive systems 0.11. The reason the massive systems are less is because of the mass of wood in those elements, such as the cross-laminated timber or laminated veneer lumber panel. It has an inherent fire resistance as well. So it was considered, based on the analysis, that these would reasonably apply to other non-residential or non-healthcare type occupancies. From a high-risk perspective, that was broken up into a couple of key tasks. One was for these Class 9A buildings, which are typically such as hospitals, where under our deemed to satisfy, you could use just a zone pressurization system. For the aged care style buildings, our Class 9Cs, automatic sprinkler systems are mandated, so they are required. Although in our non-combustible construction, you can actually have some combustible elements. So certain internal walls and floors can be used also with a lower fire resistance level because of the use of sprinkler systems. So we had to take all of that into account. So the analysis found for our hospital type buildings, there was a large reduction in risk to life, just due to the introduction of the automatic sprinkler systems. So the reduction was in the order of that 60 to 90%. For our aged care style buildings, the risk is similar because both our timber systems need sprinklers and the non-combustible buildings also need sprinkler systems. But the comparative risk, when we looked at from that multi-scenario analysis, indicated that comparatively there was still a reduction in risk because of the use of these fire-protected timber systems. One of the issues that was raised also during the development of the code change was the performance of lightweight timber systems. So full-scale fire test was undertaken to achieve a 90-minute fire resistance level. So we used a range of different lightweight engineered floor systems or floor elements. We used fire-grade plasterboard on the underside, and we undertook a full-scale load-bearing fire test. So the test achieved the 90-minute performance. As you can see, the fire-grade plasterboard's taken quite a bit of a test, but still managed, the timber floor joist elements still managed to maintain load for that full test. So basically what has occurred through all this analysis and full-scale testing is we've achieved a code change in Australia as of 2019, which basically enables all classes of buildings to be built using timber-framed elements, be they timber framing systems, lightweight, or our massive timber systems, up to around about the 8-storey level. Now, there's a fair bit of work that went through the analysis to undertake that analysis, and it's described in a publication that we've got available free of charge online through the woodsolutions.com.au website. So it's around about 250 pages. It describes the work that was done to enable us to get a code change back in 2016, but the same approach is now being used beyond that. So look, I'd like to thank you for your attention, and I hope that's given you some background as to the work that's been done to achieve our code change, and I wish you all the best. Thank you.